Hello, friends. I'm Ashish Darbari, founder and CEO of Accemize, and it's my pleasure to welcome you. If you're listening to us for the very first time, this is our regular weekly podcast, and for the listeners who've been used to our podcast, welcome back. I'm really excited today to welcome our guest to our podcast, Harry Foster, Chief Scientist at Mentor Graphics. We have a lot of interesting conversation to follow, friends. So welcome, Harry.
Thank you.
So you're the chief scientist at Mentor, and sounds like an Uber lord at all things technical. I've known you for a number of years, but can you tell us how you ended up pursuing science as a career and ended up in VLSI?
Yeah, so let me basically go back to the first part of the question about, the Uber Lard thing, that the role of chief scientist. And that actually happened with the general manager and senior vice president at the time at Mentor was Robert Hum. He since has retired, but he was concerned about there wasn't anybody looking over the horizon in terms of medium and long range trends, challenges, and opportunities. And he was afraid we had missed something. So he asked me if I'd fill that role. And that's basically what I do today. It's bridging these industry relationships with academia and research. And this has led to, by the way, a lot of the industry trends that I've been involved in over the years. But concerning how did I pursue sciences, and that itself is kind of a funny story because I actually started my academic career as a music student. And like many music students, there comes a point in time where you ask yourself the question, do I really want to eat when I grow up? And so, humor aside, I made the decision to switch to sciences. And the reason there's actually a correlation between math and music. A lot of people talk about this. And so I changed to electrical engineering with a minor in math, and I have no regrets about that decision today.
Excellent. I have heard this kind of a story from about Donald Knuth. You might have heard of him in computer science, Stanford University professor. He also had a lot to do with music, maths, and computer science. So it looks like they're quite closely related. These threads. When did you actually join Mentor?
I joined 14 years ago in 2016, and by the way, the reason I joined Mentor was that there are a lot of brilliant people at Mentor, and they all share the same passion that I do. And it's more than just selling tools, it's wanting to change the world. And the key word here, I think, is passion. I always say that people without passion are boring, and certainly many of my colleagues are not boring. And so they have passions in algorithms and in research. And then there's others that have passions in like industry standards, creating new industry standards. And another set of people that I've worked with have passions in terms of education and maturing the industry in terms of skills.
So, on a typical day, what gets you out of your bed every morning? So you wake up, and what are the things that you seem quite excited about during your day? Because 16 years at Mentor Graphics, and presumably you have been in other companies before, such a long career you have had. How do you keep yourself going on and on?
I think it's a combination of all these things that I just mentioned. For example, I really do have this passion in terms of education, my involvement with the Verification Academy. Um, and it's actually interacting with industry people, customers, and figuring out what are a lot of their challenges in terms of successfully adopting these things, and how can we address that through education. So that's one of my biggest passions right there.
Yeah, I'm glad you touched about Verification Academy. So, if I'm not wrong, you are one of the founding members of the Verification Academy. And also, I suppose you have been involved with Accellera for a very long time. So, tell us a little bit about how you've been involved with Accellera because it's a very important organization shaping up so many of the different standards that we all end up using in industry, and you guys build software around it. So I actually don't know that much about your involvement with Accellera, and I think a lot of our listeners might be interested to know your journey with Accellera?
Yeah, yeah. So my I got involved with Accellera back in the late '90s, in late '90s, 2000 timeframe, and what happened was that there was this interest in developing basically a property language, which ultimately became PSL. And so I participated in this, and then I was asked if I wouldn't mind leading the working group, the IEEE working group. It was Accellera at that time, a working group on a property specification language, as we know as PSL. And so I was involved in that, and then that led into work with system Verilog assertions, as you know, the PSL basically semantics were aligned with system Verilog assertions. At the same time, I was at Hewlett Packard. I created what became known as the OVL, which Accellera ultimately turned into a standard. And this is the Open Verification Library. And that has an interesting story itself. The reason I developed that was that at this period of time in the late 90s, I was evaluating a number of formal tools that were coming about from various startups. And each one of these startups had their own proprietary property language. And that was frustrating because every time I evaluated a new tool, I had to go in there and rewrite the cryptic notation for these temporal logics, these proprietary languages that were being developed. So I introduced this abstraction layer that had clear semantics on specific properties. And then I was able to create a library, basically of properties. And when I evaluate a tool, all I had to do was update the library with their particular notation, and I could very quickly evaluate different tools. But the interesting thing we found was that engineers, they had no interest, design engineers had no interest in these
Yeah.
model checking tools,
Yeah.
but they were putting these assertions and properties in their design and running the simulation. So they were getting benefit in terms of debug. But anyway, that led into the OVL. The OVL was donated to Accellera, and Accellera, ultimately standard,
Yeah.
created standard on that.
So this is really fascinating, Harry, because I've been associated with formal verification for some time, and I've used Intel's proprietary languages as part of my PhD work. And you're absolutely right. There seem to be quite a few languages, and I think not many people appreciate, I suppose, even in the academic side of formal verification and computer science, is that these contributions, like you've pointed out, the invention of OVL, which a lot of people might say, oh, what's the big deal about this, another language? It was just another language. But it was not just another language, because this enabled a lot of designers to catch on with writing assertions. And I remember back in the days I used to work at ARM, they've had a big history of using OVLs, and I'm sure ARM wasn't the only one. And these milestones, I think we don't actually know them very well. So actually, I'm very thankful to you to bring it out today, because these are real solid milestones that have enabled so many of us in the industry to start understanding the impact of assertions, even in simulation, never mind formal, right? And that's the,
Yeah. In fact, I know that one of the reasons ARM was interested in OVL was that they wanted to ship IP with checkers embedded in them. That they could basically check the integration of the IP and determine, was it an integration problem or is it really a design problem? It made them a lot more productive in terms of engaging with their customers.
yeah, absolutely. So tell us a little bit more about your role at Verification Academy, and from the point of when it came into being and to where it is now, what has changed, and tell us what's going on at Academy these days.
Well, so the Academy idea, I started about 2007, 2008 timeframe. And what happened was I had just finished one of the industry studies that I do periodically, about every 2 years. And what I found somewhat surprising was that there was a lot of low adoption what I call just fundamental techniques. For example, code coverage. At that period of time, it was like only 45% of the industry had adopted it. And I'm kind of scratching my head thinking, wait a minute, this has been around since the early 90s. And there's a low adoption of this as well as many different techniques. And I then came to the realization that it wasn't so much a technology aspect of lack of adoption. It was a lack of understanding in terms of process and methodology. How do I integrate this in the flow? And so I thought, if I could mature people in terms of skills of that type of understanding, we could increase adoption of these different techniques. And that's what we've done. In fact, today we have over 62,000 members.
Wow.
It's the largest community of verification engineers anywhere, and we're constantly expanding. We started out with a bunch of video courses. Today we have over 300 recorded videos out there, constantly expanding with new topics. Recently we've added some on PSS, which is property specification link, portable stimulus standard.
Yeah.
And then we've added new topics on safety and a lot of these hot topics that are emerging. But we've also created cookbooks because if you think about it, UVM is non-trivial. It takes a lot to mature skills
Sure.
there. And so we've added specific cookbooks on that, on coverage-driven techniques, as well as added a forum out there where engineers all over the world can ask questions and other engineers someplace else might answer it. So this whole community has come about, and
Yeah.
I'm just really surprised and amazed how it's taken off.
Yeah, what is really nice about the academy, Aximize is a member of it. I've contributed to Verification Horizons blog. It seems like it's a very open, transparent framework where people who have something useful to contribute can do so, and there is no real allegiance to mentor graphics as such or anything. This is not about marketing. This is about actually disseminating technical know-hows about things that affect day-to-day design verification, which is, I think, the best part of the academy. It's a very open institution, which is fascinating. And having started Aximize only a couple of years ago, I do understand how hard it is to start building these pieces from scratch. So I can totally relate to some of the early challenges you must have faced when you kicked off the academy. So Harry, one interesting thing I picked up recently was your blog on FPGA, which I think you were sharing about a couple of weeks ago. And I, in fact, picked up that this was prepared not specifically with any reason, but you were going to give a talk in Norway. You were invited to give a talk. So tell us, what is this blog about, and how did this come into being?
Well, so the blog essentially is promoting a recording I put out on the Verification Academy. And so stepping back, I was invited to give a keynote at this year's FPGA forum in Norway. And my topic was basically on FPGA maturity in terms of verification processes. And it was this quantitative analysis I had done on it based on one of my recent studies. And then when I went to DVCOM, because there was a number of sessions that were canceled, I was asked if I could redo that basically keynote, which I did, and I had a lot of requests if people could get a copy of it. So what I did was recorded it and put it out on the Academy. But the main topic that I talk about there is some interesting trends related to FPGAs. For example, in the ASIC world, we have this notion of spin, or number of respins, and we use that to basically as a metric to measure the effectiveness of the verification and validation process. We don't have a similar type notion in FPGAs. And it's always frustrated me because you really can't tell how effective are these guys really in their overall process of verification and validation.
Indeed.
So 2 studies ago, starting in 2016, I introduced this question targeted at the FPGA participants. Since I couldn't ask them how many spins, I asked them, did you have a non-trivial bug escape into production? And I was somewhat alarmed by what I found in 2016, where only 22% of FPGA projects were able to achieve no bug escapes into production.
Wow.
And that grew in 2018, or actually shrank, where only 16% of FPGA projects were able to achieve no bug escapes in production. The significance about that is that there are some market segments, such as Mirror, where if you take the cover off the system to upgrade the FPGA, you have to revalidate the entire system, which the cost can be enormous.
Wow.
So this mentality, we can just simply fix the FPGA, starts to fall apart.
Yeah.
And so the other interesting thing I did in this last study was I then looked at the FPGA projects and partitioned into two independent groups. One group had no bug escapes into production, and the other group had bug escapes in production. I then did an analysis on what type of verification techniques they had adopted, because that was something I had from the study. And what clearly came out of this was that projects that were mature in their verification processes, adopting formal, adopting constrained random, all these different techniques, they were statistically significant in terms of having no bug escapes into production. Sure. In other words, these techniques do work. So I actually could quantify that. So anyway, so that's what the blog was about, talking about the recording I had done on this. Incidentally, so I do have recording out on Verification Academy. I also have papers published at IEEE on their Explore that was originally from MTV that's focused only on FPGA trends. And the reason I'm somewhat excited about this, there's a lot of industry studies that have been done on ASIC ICs, but very few on FPGAs. So this is one of the first published papers specifically focused on FPGA verification trends.
In fact, I would strongly recommend our listeners to go and check these things out. And I think you and I should actually talk about FPGAs on a specific chat thread, because I've been following the development of FPGAs ever since my student days. And what I've come to see is that they are the next big thing that's going to happen in the way custom hardware and custom systems are being built. And so it's a good time to understand what makes these things work successfully, and as you said, become an early adopter of the best practices. So it's not rocket science. It's not rocket science, but again, one of these things that not a lot of people actually understand how to get on with these things.
And what's interesting now in the FPGA space is there's this growing trend about doing these basically accelerators for the data center. They might be some sort of AI accelerator or other type of accelerators. So the market is really just taken off.
Yeah, it is a fascinating topic. So actually, you mentioned something about the surveys, and I wanted to pick you up on that one. So every couple of years, you carry out a big study across the industry, across the world. Tell us a little bit more about this, because I'm not sure all our listeners actually are aware about it. I'm personally aware about it, but it would be nice to elaborate on the specifics of these studies.
Yeah, so in 2002 and 2004, Ron Collette International did a bunch of well-referenced industry studies on verification, functional verification. And unfortunately, after 2004, Ron Collette International stopped doing those. And so we had this void in the industry of understanding what are the trends, what's happening in terms of functional verification. So Mentor picked this up in 2007. And we wanted to maintain this as a credible study in the sense that it's a double-blind study. The participants in the study are not exclusively Mentor customers, and that's a key point. Otherwise, it'd be a biased study.
Absolutely.
And so it's, in a way, somewhat double-blind in that this pool is put together, targeted for the study, and then I do the analysis, and I don't know who, like, were you from ARM or Intel, whatever. I don't know where you were from when you answered the question when I do the analysis. We do these studies every 2 years. The last one we completed in 2018. I'm in the process of putting together the 2020 study, which will kick off in a few months here. These studies are also, a lot goes into it to ensure the integrity of the study. For example, it's not just an open invite, go tell your buddies to go fill this thing out 50
Sure.
times or something.
Yeah.
There is a key that's given that can only be used one time. And as I said, a lot goes into ensuring the integrity of the study. So if people were interested in reading about the studies, if you go to the Verification Horizon blog, I have a whole series that covers all the studies that I've done, and so you can get data on the previous studies.
Yeah, it's a very, very important piece of work in our field because there's really nothing else out there that gives this kind of information about developing trends, trends that work well for customers. Where is the industry going? So, hats off to you, man, for actually pulling this off so well and for so long. And as you said, all of this, making it double blind and preventing uh, orchestrating this in an unbiased way. This is all hard work. Very nice. So one thing that's always you know been on my mind is depending on who you talk to and which customer you talk to, they will say that top verification challenges are, oh, emulation is not very fast, formal doesn't really work, or simulation is not giving me enough coverage. And it is understandable that depending on which customer you're talking to, they have unique challenges. But I cannot think of any other better person to ask this question other than you. If you were actually saying what were the top verification challenges based on your experience, based on the numerous studies that you've seen, what do you think is blocking the industry in adopting the best of simulation, emulation, formal, or FPGA? Can you tell us how to move faster?
Yeah, so I think first of all, it's important to recognize today that there's no single silver bullet in verification. There's not
Indeed.
one single tool that we can use that would basically address all issues that we're trying to verify. And so, really, what's driving this, in my mind, is this explosion of new requirements that's happened over the past 10 to 15 years. Um, and you think about that, whereas that we started years ago, we focused predominantly on the functionality. We started adding clocking requirements, power requirements,
Sure.
safety, security, performance, and now even software. It's just this explosion. So the reality is, it's no single tool that we can use. We need all these different tools. I think one of the problems I see is that many projects don't put in place a verification architect who's looking holistically across the flow and understands, they're not necessarily an expert on all these different techniques, technology, but they understand the appropriate time to use them, when not to use them, how to put together a total flow, and then how to plan for that. That's something I'll harp on a lot. I know you've harped on it a lot too.
Yeah,
Many
yeah.
cases, a lot of failures we see is the fact that there wasn't proper planning done. Particularly with formal, a lot of cases I see somebody will pick up a formal tool, want to try it out, they're real excited about it, they write some ad hoc assertions. At the end of the day, they clearly don't show any return on investment, and they didn't plan for it. So planning is very important. And then the other aspect is maturing skills. I think a lot of companies uh, don't put enough emphasis on that in terms of maturing skills. An example I like to give there is that if I were going to sell you, let's say, a simulator that did constrained random coverage driven verification, that all sounds good. And ask the question, would you succeed? The chances are probably pretty low until your organization develops object-oriented skills as well as skills in system Verilog and UVM.
Sure.
Once you develop those skills, yes, you'll get the most out of the tool. The same is true like in formal. If you don't develop the proper skills about, a proper way of writing properties, constraints, how to introduce abstractions when needed, knowing what to verify,
Yeah,
putting in place
absolutely.
metrics to measure success. Without all these, it's hard to get an ROI. So I think that's really, in my mind, the biggest challenge is to addressing the planning aspect and developing skills to get the most out of all these technologies. The reality is we need them all today because there is no single silver bullet.
So in a sense, what you're saying is it's understanding the scope of these individual verification technologies and how do you combine them, but planning and process and skill development all have to be considered in holistic manner, not just by a specific expert in a specific verification technology area. In fact, Harry's last week's podcast, I was actually talking about some of these issues because I feel the same way that actually, yes, all of these technologies are great simulation, formal emulation, but none of these on their own can actually solve all the verification challenges. And I don't personally believe that actually any one person in the world even knows this answer of what would be a universal way of combining these things because the context in which these things have to be combined varies so widely. It's absolutely fascinating when you see these things being combined in a genuinely interesting way because then you can see that it can be done. But most organizations, I think, are still trying to understand just some of these, not all yet, right? I know from formal side
Yeah,
there's still a lot of catch up to do, and for UVM as well, I think people have been using UVM, but have they been using properly and in a holistic way? Is anybody's
yeah.
guess.
I think there's some fundamental principles that probably. Well, not probably. I'm sure that basically would go across many different projects, but then again, there's a lot of domain knowledge that's required specific to the project to figure out the effective combination in the way these technologies interact, and that's again a very unique skill, and that's the reason I find often that projects that do have a verification architect do much better than those don't because they can look across this and understand not only the technologies and I have in this set of tools, but also the domain knowledge specific to what I'm trying to verify.
Indeed. So, Harry, I just wanted to touch upon formal verification a little bit. It would be hard for me not to talk about formal, but um, you're not a PhD in formal verification, and you have defined assertion languages, as you pointed out. You've used them. You have talked about successful deployment. How did it all happen? How did you get interested in formal? I know I've read your article, which was about being a vegetarian and being a formal verification person. Both are quite hard activities. We all know we should be doing it, but not enough of us do it. So, how did this happen? How did you end up being so successful at formal without being a PhD?
Well, so what happened was I was working for a supercomputer company back in the late 80s, Convex Computer Corporation. Ultimately, they were acquired by Hewlett Packard. But at that point in time, uh, we were moving from gate level design to RTL design, and we saw this tremendous increase in productivity, about as you can imagine, for doing design. At the same time, we saw our gate level simulations increase, one or two orders of magnitude due to the productivity in design. It actually put the burden on verification. So I started toying with the idea of creating what we call now is equivalence checking. I didn't know at that point in time there really wasn't much written
Yeah,
on it,
yeah.
and so my background in there prior to that I was creating tools that basically pattern generates ATPG
Oh,
for
yeah.
tests. So what I did was I took two versions of design, an RTL version and a gate level, connected together with an exclusive OR, creating what we now know as a MITRE. And then I took the algorithms I had developed for ATPG and tried this out.
Right.
And the funny thing was that, oh sure, I could prove equivalence or actually find bugs on toy circuits. And so then I started digging a little bit deeper, and at this point in time, as you are aware, BDD started to come about,
Sure.
and so I started trying out BDD engines, as well as trying some other techniques. For example, taking the cone of logic into the design and finding cuts that I could basically identify as potential equivalent signal pairs. So I could really shrink the problem down, and then all of a sudden, wow, yeah, we could prove amazing things with this combination of BDDs and partitioning the design down into smaller pieces. And then by 1993, we completely gave up gate level simulation. So that was the beginning of my understanding about formal. So then I started exploring in terms of model checking, and of course in the 90s the tools were just by today's standards really toys.
Yeah, true.
And there were a few commercial companies that came about, and so, but the good thing about this was that it led to development of assertion-based verification, which is not only formal, it's also benefits in terms of simulation. And
Absolutely.
so, although at this point in time we didn't see the benefits in formal, we did see benefits in reducing debug time. Uh, but that led into my work with temporal logics and assertion language standardization. So that's basically the history there. And then I went to work for Verplex. Again, my background was equivalence checking. And I worked with them on both model checking and equivalence checking. From there, I went and worked at Jasper for a while before I went to Mentor. So that's my roadmap.
But this is really, really fascinating, Harry, because not having a background through academic qualifications informally, your whole career is a proof in a non-mathematical way that you can actually, have a thriving career based around applications of formal and slowly get to know the in-house and fascinating history. You talked about equivalence checking, and of course a lot of us now take all of this for granted. When we're doing synthesis between gate level and RTL, we don't even think twice. I've come across a lot of people when I was teaching them formal, they often think of formal as just equivalence checking between gate level and RTL, and they're not wrong in that way, but it's just absolutely fantastic. So Harry, I would like to wrap up our chat today, but before I wrap up, I wanted our listeners today to take away 5 tips from you to become productive with their design verification, and tell us what it should be if you only had to give 5.
Okay, only 5. I think first of all is don't ignore process and methodology. That is so fundamental. And by the way, I did listen to your blog last week, and there was an excellent discussion on that. But that's typically something that's ignored, and it's generally, in my mind, creates the biggest problem. The other thing is a recommendation would be like constantly triage the process and figure out where the strengths and weaknesses are. For example, if you find a bug, let's say running emulation, the question the team should always ask: should we have found this earlier? And if so, how can we modify the process so we can find it earlier? There are certain times where you can't find bugs earlier, particularly if it requires integration of hardware and software. But that's a very important question to ask, and I don't see it asked enough. It's the only way that you can refine and improve the process. And then it's important to introduce metrics into the process. We think of metrics, often as coverage, but that's pretty simplistic. Some have bug rates. That's important. Bug densities is actually important too. You can get insights very quickly about, we're going to have problems in this particular portion of the design. Is it something to do with the way the design is designed, or is it we've got a junior person that we need help there? Anyway, it's answering those type questions. Regression performance. There's a lot of metrics that should be introduced in process. A process without metrics is useless because you don't know if it's effective. So I think that's That's very important. The fourth thing would be, we've harped on this today, the importance of developing skills within the organization. You really can't take advantage of any of these advanced techniques without building the proper skills. So that's pretty fundamental. And then the final thing, I think, goes back to kind of like what we opened up this discussion, is that find a passion and pursue it. Again, people without passion are boring, and there's a lot of passionate people in verification, whether it's formal or whatever. But it's important to pursue that passion.
Wow, yeah, that's a really nice summary of these 5 tips. I am happy to say that I relate to a lot of these. But yeah, I would like to thank you, Harry, for your time today. I know you're a very busy person and you've got a lot going on, so you spared this time for us. We're very grateful. I'm sure our listeners will enjoy this podcast, and we would very much look forward to welcoming you back and dive deep on some of these topics. So thank you very much.
Thank you.
So if you like today's podcast, please let us know. Subscribe to our YouTube channel. Ping us at info@aximize.com. And most importantly, stay home, stay fit, stay healthy, and we will get back to you next week. Take care.